Moving on to 5B, this is what we're really here to do. We were just addressing issues that the client had there, mainly about the amount of seed data, so that's done. So we're going to go on and talk about the next important relationship. Again, remind you of our basic assumption that unless otherwise noted, all of our primary keys are integer identities, simply called ID, right? Okay, so we dealt with two different flavors of one-to-many relationships last time we were in this PowerPoint, right? Now we're going to talk about a no payload many-to-many, right? Basically where you have two entities that are in a many-to-many relationship, right? And then, of course, in the database, we actually do need a intersection or associative entity or table, right, to support the many-to-many relationship. So in my example here, we're talking about something familiar. A student will take many courses. A course has got many students in it, right? So if you didn't, by the way, like enrollment just jumps right out at me as a reasonable name for the associative entity. If you didn't have a reasonable name, what the convention is just to concatenate together the name of the two parent entities. So it could be like student course or course student, right? Either one is perfectly acceptable. But if there is something that is kind of meaningful way to describe the relationship, a noun that does that, then that is the preferred name for the intersection or associative entity. Okay, so in our case, enrollment. So what it goes inside enrollment? Well, no payload means there's no actual data stored in this table, right? The enrollment table in this case. No data other than basically the two foreign keys. Now we have already seen that when we cast, so to speak, a foreign key from one entity into another, because really what is a many-to-many? It's two one-to-many relationships with a common child, right? That's really, so student to enrollment is a one-to-many. Course to enrollment is a one-to-many. So not surprisingly, we see the same arrangement we've had with our earlier many-to-manys in that we have the object, okay, a student object combined with a student ID integer value, which is our actual foreign key. Then we have our course object and the course ID, right, following our naming convention. Of course, the IDs, the primary keys in course and student are just ID, right? There we go. Okay, and that's all that goes in that table in the middle, right? So how do we make a primary key? Every table needs a primary key, so we do a composite key, and we'll do that with the Fluent API, right? Just a note there that this will be managed, okay? We aren't going to create even a controller for enrollment, right? We'll manage, okay, these enrollment records, so to speak, from one of the two parents, maybe sometimes from both, right? We'll often use things like checkboxes or list boxes where you can select, okay? So, for example, on the student page, you might check off all the courses that they're enrolled in, or you might select them out of a list and move them from the choose from list to the ones you've chosen, that type of thing, right? So that's basically what we're going to do. So what's involved besides the classes themselves? Well, inside the DB context, of course, we have to have a DB set, even though we aren't going to make a controller for it, for that associative or intersection entity, okay, in our case, enrollment, right? And in on-model creating, okay, that's where I mentioned we're going to create this composite primary key, right? So this little bit of code in there will, okay, go to our model builder, ask it for the entity enrollment. We're going to say it has a key, which is made up of, with this lambda expression, this combination, this new combination of a student ID and a course ID. Perfect. That's exactly what we need to do. Just a note there that we typically use checkboxes or list boxes in the UI when there is no payload. There's nothing else to store in here. So, really, we could almost ignore this entity, okay, except that it's there to support the relationship itself. All right, so that's the end of our discussion. Let's get into actually doing it. Oops, I forgot I had one more slide here to talk about. Okay, what often happens when you get this kind of arrangement, right, is what about that whole issue of cascade delete? Because really, we mentioned that it's really essentially two one-to-many relationships. So what if you delete a parent record on either side? Well, what we'll usually find is you do want to restrict from one side and not the other, right? So for example, it makes sense that if you're going to delete a student, if you really are going to take them out of the system, why would you leave enrollment records for them behind, right? So you would want to delete, okay, the enrollment records if you actually took a student out. On the other hand, okay, from a course to enrollment, you would probably want to be prevented. You shouldn't be able to delete a course if there are students enrolled, right? So the rules can be different on each side of a many-to-many relationship like this. So typically we would do something like what you see here in our Fluent API, okay, for the enrollment, okay, to the course. And you can do it from the parent to the child, child to the parent. It's the same relationship, right? So I'm just showing you alternate ways. But basically, once you identify what relationship it is, the one between enrollment and course, we're going to say that delete behavior is set to restrict, right? In other words, you can't delete a course if there's students enrolled. We will allow you to delete a student and then just have the system automatically delete all the related enrollment records. All right, that is the actual end of our. Now, of course, we're going to go on later on and look at a loaded intersection or associative entity where we store additional data in it. But for now, let's just keep it simple and focus on one at a time.